Hello, everyone, and welcome. My name is Brandon Kwa, and today I will be discussing quantifying environmental impact, insights from ecological footprint, and life cycle assessment. This presentation is part of my assessment tool for SSM5073 Sustainable Agriculture and Food Systems, and it is tailored for the general public across Malaysia. In this presentation, I will introduce three key concepts: environmental impact, ecological footprint, and life cycle assessment. We will look at how these tools help us understand our consumption of natural resources and the waste we produce. I'll then assess their strengths, limitations, and how they compare. I'll conclude with insights of what it means for our future. This footprint represents the different human activities from industrial production, transportation, farming and livestock, and built up land. It visually captures how our environmental impact stems from every stage of our economy, including resource extraction, production, and waste. This idea connects directly to the ecological footprint concept, which measures the total area of biologically productive land and water required to supply our needs, such as crops, livestock, forest products, and fishing grounds, while also absorbing the waste we generate. Essentially, the image shows that each part of our modern lifestyle, from industrial outputs to the food we consume, draws on the planet's finite resources, all of which contribute to the overall footprint. At the same time, the image hints at the value of life cycle assessment. LCA looks at the full journey of products and services, from the materials and energy used in factories to how goods are transported, consumed, and eventually disposed of. Each stage contributes to the environmental impact we see here in the footprint. By analyzing these stages in detail, LCA helps identify the biggest hotspots where we can reduce resource use, waste, and emissions. Together, the ecological footprint offers a big picture view of our total demand on the Earth's resources, while LCA drills down into the specific processes that drive that demand. Both approaches showed us that our choices, like how we power our cities, raise our food, and build our infrastructure, matter. They help policymakers, businesses, and individuals see where we can make more sustainable decisions and shrink our footprint for future generations. Each of these tools has its own strengths and limitations. The ecological footprint is universally applicable and simple to understand, making it highly relevant for broad policy discussions. However, it is limited by its generalized, static nature and tends to overlook specific environmental factors like biodiversity loss. On the other hand, life cycle assessment provides a comprehensive, transparent, and dynamic analysis that can pinpoint specific areas for improvement within a product or process. Its downside is that it is data intensive, often subjective, and can be complicated to execute. Understanding these strengths and limitations helps us decide which tool to use depending on the context, sometimes even using them in tandem for a more complete picture. We assess the ecological footprint because it shows us how much natural resources our activities consume and the waste they produce, compared to the Earth's ability to regenerate those resources. This offers a big picture view of our environmental pressure, which is particularly useful in policy making and public awareness. Imagine the Earth produces what we need: food, energy, transportation, lumber, and land for settlements. And the environment has to absorb the waste we generate from these activities. This is known as footprint. And if this is not balanced, we end up polluting the Earth faster than it could regenerate. The ecological footprint is a tool that quantifies the amount of biologically productive land and water area needed to support the resources we consume and to absorb the waste we produce. It is expressed in units called global hectares, which provide a standardized way to compare different types of land and water. To break it down further, think of our ecological footprint as a measure of the demands we place on nature. This demand is calculated across various land types. Each category reflects different aspects of resource use, whether it's the land used for housing and infrastructure or the area needed to grow our food. Biocapacity is the regenerative capacity of the earth. The ability of ecosystems to produce the biological materials we use and to absorb the waste we generate under current management practices. It is measured in terms of several land types, such as built up land, fishing grounds, forests, grazing land, and cropland, which together indicate the sustainable support available for a population. When we compare our ecological footprint to the biocapacity, we can see whether we are living within sustainable limits. For example, if our ecological footprint exceeds our biocapacity, it means we are using resources faster than nature can replenish them, a situation that leads to an ecology debit or deficit. In our Malaysian context, historical data shows that while we once had an ecology credit, over the years our biocapacity has declined and ecological footprint has grown. This gap highlights the unsustainable pressure we are placing on our environment. Understanding these concepts is crucial because it helps us identify where our consumption patterns are unsustainable and guides policymakers in creating strategies to reduce our environmental impact. By knowing exactly how much pressure we're putting on our planet, we can work towards more balanced, sustainable practices. This comprehensive view provided by the ecological footprint is essential as it sets the stage for more detailed analysis such as life cycle assessment, which we'll discuss next. Ecological footprint provides a simple, universal measure of how much of Earth's regenerative capacity we use. Its clarity makes it an excellent tool for communicating overall resource demand and waste production to both policymakers and the public. However, it primarily focuses on biophysical factors, often overlooking important issues such as biodiversity loss, pollution, and social equity. Additionally, it offers a static snapshot of resource use rather than capturing dynamic changes over time. Now, let's shift our focus to life cycle assessment. LCA is a comprehensive tool used to evaluate the potential environmental impacts of a product or service throughout its entire life cycle. What does this mean? Essentially, LCA examines every stage from the moment raw materials are extracted through production, distribution, and usage, all the way to the end of the product's life, which includes disposal or recycling. This systematic approach allows us to identify hotspot stages in the life cycle that contribute the most to environmental impact. For example, while a product might have a low impact during its use, the energy intensive production process might be where most emissions are generated. LCA helps us pinpoint these areas so that improvements can be targeted effectively. One of the major strengths of LCA is its comprehensive nature. It provides a transparent and dynamic view of environmental impacts, which is particularly useful for comparing different products or processes. Decision makers, especially in industry, rely on LCA to choose alternatives that have lower overall impacts. However, it is important to acknowledge some limitations. LCA is data intensive and often resource consuming. It requires detailed input data for each stage of a product's life cycle. Additionally, the result can be somewhat subjective, depending on the boundaries and assumptions made during the assessment. And finally, because of its complexity, LCA can be challenging to implement without specialized knowledge. Here are some critical insights. Firstly, neither tool fully captures aspects such as biodiversity loss or social equity. Secondly, while the ecological footprint provides an important macro view of resource use, LCA's detailed breakdown is essential for operational improvements. Together, they inform public policies such as Malaysia's National Green Tech policy and the Green Technology Master Plan, which aim to reduce our environmental impact. By understanding where our greatest pressures lie, policymakers can implement targeted measures to boost resource efficiency and protect our natural heritage. I would like to leave you with a few recommendations. First, on an individual level, take time to understand your own ecological footprint. Be mindful of your energy use, waste, and consumption patterns. Small changes like reducing energy consumption, recycling more, and supporting sustainable local products can add up to significant improvements. For our policymakers and community leaders, I recommend integrating life cycle assessment and ecological footprint analysis into decision making. These tools can help shape policies that promote resource efficiency, protect biodiversity, and guide sustainable development initiatives, ensuring Malaysia's growth is balanced with environmental stewardship. Ultimately, by embracing these approaches and making informed choices, we all contribute to a more sustainable and resilient future for Malaysia. Malaysia is facing a significant sustainability challenge with our biocapacity diminishing as our consumption grows. I encourage all of us, citizens, policymakers, and businesses, to consider these insights seriously as we work towards a more sustainable future. Thank you for your attention.